Hi there. This is session 13 of programming from the very basics using Python. So in this video, I will talk about the for loop, usage of for loop in Python. In the previous session, I talked about the while loop and its usage with some examples. And we all learned the difference between the for loop and while loop. In summary, if at all you want to do conditional looping, you go for a while loop, a loop based on a condition. You want to execute a series of statements repeatedly based on some condition, then you'd use a while loop there. But in case you want to, let's say, iterate over elements in a collection or any other iterable objects, or you want to, let's say, perform some series of statements repeatedly a number of times, you want to decide how many times you want to perform them. For such use cases, it's more logical to use the for loop and not the while loop. So let's get started with the for loop in this session. So I'll tell you what it takes to get started. The basic way of using a for loop for counting iteration is using the help of range construct. So I can actually use for I in range of a number like this. And when you use the block like this is the syntax. You say for a variable that will be used as an item in an iterable. Now range might look like a function, but I should tell you that range is a data type. It's also classified in the built-in type. So the range returns an iterable, and using this iterable, you can iterate over numbers. More about range in the next session, perhaps. But for now, I will just tell you how to use it. So I'll tell you about the internals about it, iterated protocol, and how to use it, and how range falls in that space, and more about that in the next session. For now, we'll learn how to just use range and get with it. So we can just try for I in range of 10 by just print I. It's just going to iterate starting from 0 up to 10. Remember, whatever number you pass to range, that is not inclusive, which means that it's going to iterate till that number, not including that number. This is also called as a stop index or stop value, right? The stop is passed as an argument here. By default, the start is 0. It stops at 10, right? It means before 10, it just prints that and it stops right there. So yeah, one more thing is sometimes when you use print like these and you don't want each print to have its own new line, you know what to do. You can always use print I, comma, end is equal to, you can use any other end specifier. Let's say I can use a string, you can put a space like this, and it comes up this way. Or maybe if you want to separate them by commas, you can also use comma space. Any string will do. It's going to separate with those strings. And yes, it ends with a comma at the end. You can see that. The last print ends with a comma. Yeah, that's some subtlety that you should live with. Now, this is how you use a basic for loop. And now a little bit about what are arguments you can pass to range. So if I use range of just one argument, it's going to start from 0 up to that number. But if I want to, let's say, try out between two numbers, I can say range of 10, 20 like this. You can see that it starts with 10. Yeah, start index is inclusive. Stop index is not. Okay. So when you say start from range 10, 20, this first argument becomes the start. The second argument becomes the stop. It starts setting the value of I. What really happens is the I as a variable first represents a value 10. Then this block gets executed, which just has a simple print statement in this case. So it just executes this block with the value of I set to 10. And then it goes back again and sets the value of I to the next value, which is 11, then 12, then 13. It goes all the way till 19 and it stops. So this is how it works. You can also, let's say, use a step value if you want to. You can try for I in range of 10, 20, 2. When you call range with 3 arguments, it's start, stop, and step. So step will indicate the increment value. By default, when it starts with 10, the next increment by default is 11, after which it's 12, then 13. The step value is 1 there. But if you set the step value as 2, as you can see the output when I run this now, I still run this, so I'll run this now. You can see it's 10, then 10 plus 2 is 12, 12 plus 2 is 14, 14 plus 2 is 16, and it goes on. You can try all kinds of variations. Maybe you can even try for I in 10 to 50, for example, and try some step value as 5. Show me all the multiples of 5 from 10 to 50. Yeah, you got it. In fact, if you have these kind of exercises where they ask you to generate even numbers or odd numbers, these are some basic academic exercises. The Python way to do it is pretty straightforward. All you need to do is just indicate the start value. Let's say start from 0. You want to start, maybe I want to generate even numbers from up to 20, the first 20 even numbers. I can say 0, 20, and 2. 0 to 18. Or maybe you want to generate odd numbers. The only thing you need to do is start the start value. You can start with 1. That's it. So if you just want to generate odd numbers, start with 1. The step value still remains 2. Right? So you can just see this. So this is how you can use range alongside with for and perform iteration over a count of numbers based on what range provides. So in summary, I could say that range is a for loop helper. It's used primarily to aid in implementing counting iteration using for loop. That's what range is primarily meant for. Though you can use range in other purposes too, but this is the primary use case. So the next thing I should also talk about is iterating over collections. So if you want to iterate over any kind of collection in Python, you can use a for loop to do it. So let's start with a tuple. So I can just create a tuple. I'll just say nums is equal to, you can use some numbers. It's quite random in here. So I'm just going to use some numbers, whatever the numbers are. And if you want to iterate over each item of this tuple, you can actually use a for loop here. You can say for, this time I'll use another variable name. I'll say v to indicate value, right? So v in nums, I can just say print v. And usual, I'll end with a space this time. Yeah, it's iterated over numbers, right? So you can actually see that how you can iterate over a tuple just using a for loop. And you can see that when you say for v in nums, what it does is v would be set to the first value of tuple, and then it's going to execute the block. Then v becomes the second value, then the third value, fourth value. It goes on till that collection ends, and till there are no more items in the collection. This is called iterating over a collection. Though I said the word collection, I showed a tuple, but it can be even a list. So if you want to, let's say, iterate over a list, simple. All you need to do is just use square brackets here. And I told you that if you create literals with values separated by comma within square brackets, what it does, it creates a list. This is a list. You can iterate over a list just pretty much the same way, no difference whatsoever. Or you can also iterate over a set. It can also be a set. What you need to do is use curly braces, because all of these are collections, right? So you can see it iterates over a set. Of course, a set is unordered. So though I create a set like this, you can see when it's iterating, it comes in some haphazard manner. So it's not very predictable by us by default, right? And you can also notice that if at all you have duplicate elements in a set is a collection of unique items. Okay, so you can't have duplicate items in here. Looks like there are no duplicates in this collection. Is there? No, it's not. But if you try to repeat some numbers, let's say put 32 one more time, 67 another time, and let's put 12 one more time. It's just going to iterate only one time. Basically, a set, when it's created, those values 32, 67, 12 are not repeated. We can actually print it out and see that. You print nums, there's a set for you. I'm just iterating over the set in what order that is represented, right? So this is how you can use a for loop on a set. You can also use a for loop to iterate over a dictionary. So I'm going to show you that. So if I want to create a dictionary, this time I'll not call it nums. Let's say record is equal to, just going to use something like, say, name, and let's use some name. Let's type a common name called John, and let's say role, developer, and place, Seattle, and maybe what else? Maybe age, and let's say 33. Now this is a dictionary. So it's a key value mapping. A dictionary is a mapping collection. It has a mapping of key to value, right? That's how it is. You can see this is one key value pair, another key value pair, another key value pair, right? But when you try to iterate over a dictionary, I can just pass, I'll print rec here. Anyway, it'll just go to print the dictionary as is and maybe print type of rec if you want to know what the type is. But next, the statement, I'm just going to use for v in rec and just see what you get when you iterate over it. This first line is nothing but this print statement printing the dictionary, of course, and it says class dictionary. That's what you see here. But the for loop's output is very interesting. What do you see here? You see name, role, place, and age. What are they? They're the keys. It iterates over the keys of a dictionary. So if you simply want to iterate over the keys of a dictionary, you can use for, I'll not call V here, I'll say K to indicate key, using the apt names as such. You can use any variable name of your choice, but I'm just using this way. So you can iterate over the keys of a dictionary like this. In fact, some of you might ask, what if I want to get the values? Yeah, if you're able to iterate over the keys, you can always get the values of a dictionary by just simply subscripting them. So for example, you can just use, I'll remove this end is equal to for now, and I'll just use value. Okay, key and I'll not say value, sorry. I'll just say rec of k. Rec is a collection representing a dictionary. On the collection, when you use a subscript operator, that's a square bracket operator, and pass an argument to it, k as a variable, right? Which represents a value, of course, and it could be the key. You can access the value based on the key of dictionary. So this will be read as first time rec of name. Key will be name, so it'll be rec of name. Rec of name will written John. Rec of role written as developer. Rec of place written Seattle. Rec of age written 33. So if you run this code now, this is how we can access over the key value pairs of a dictionary easily. Yeah, when I talk about dictionaries, you'll realize there are a couple of other methods like dictionary.items and dictionary.values. You could also use them instead, but this should be convenient enough, right? So this is how we use a for loop. And yes, finally, I should also tell you that you could also use it on a string. Strings are also just collection of characters. Let's say s is equal to hello, and let's say for v in s, try to print v. You can see that it's iterating over every single character and printing them on a separate line. So it just printed H, then printed E, then printed L, then printed L, then printed O, because V is pointing to each character one at a time. First V points to H, then E, then L, then L, then O, right? But here's one interesting thing I should tell you. If this were a bytes object, I think I just gave a very basic understanding about bytes object in one of the earlier sessions. So if you sort of recollect that, you create a bytes object by using b quotes like this. You put a small b followed by quotes and you put some string inside it. This will end up creating a bytes object. Bytes is nothing but byte string. So every character is represented as byte values internally. When you try to iterate over it, you get numbers. You get numbers, not the characters. And these numbers are nothing but the ASCII value representation of each character. So H, small h, the ASCII value is 104. E is 101. L is 108. You can see that 108 is repeated twice because there are two L's there, and O is 111, right? So you can see that there's a subtle difference between iterating over a string and iterating over a byte. And some of you who come from C background will be a little confused because we're always in C language. We're always accustomed to represent a string as a character array, right? And we talk about character type. Sorry about this. Bad throat. Yeah, sorry. So if I just say V in S and print V, remember, though you're trying to see single characters here, each character is still a string. It's not any other type. Strings are just object. String is an object in Python. And that object is nothing but a string of characters inside it. That's how Python represents. But if you try to get one single character from the string, that character is wrapped up as another string and given to you. H is another string object now. So for every character, it creates new string objects and it returns you that, right? So that's how you see this working. Now I can see that you can use a for loop for iterating just about any collections. You should note that in Python, if you categorize an object as a kind of collection, like you can see built-ins like list, tuple, string, set, dictionary, bytes object, and all of them, you could find much more collections in various libraries, right? A lot of standard libraries have them, and you'll also get them in a lot of third-party libraries. So all of these collections, one of the primary traits they have is that you can iterate over them using a for loop, some way or the other. You can always say for element or item in that collection, and you should be able to get individual items. If it's a mapping, you'll get keys of the collection by default, right? But for other collections, you'll get the items directly, right? So this is what you should know about how a for loop can be used to iterate over all these forms, right? Now, having told you about that, there are a lot of things you can do with a for loop, because you know about counting iteration now. Let's say I want to generate the first 10 Fibonacci series. What is a Fibonacci series? If you're in computer science, you'll know it. For those of you who are new, it's a concept. It's just a mathematical series of numbers. So you start with two numbers, right? You say A, comma B is equal to 0, comma 1. Sorry. Bad throat today. Right. So A, comma B is equal to 0, comma 1. And now you start with two numbers. Mathematicians will start from 1 and 2. We computer science folks will start all these numbers from 0. Right? Indices start from 0 and all numbers start from 0 for us. So we start from 0, 0 and 1. And then to get the next number in the series, we add 0 and 1. When you add 0 and 1, what do you get? A plus B. 0 plus 1 is 1. I can store that in C. Store that in C. Right? And now after this, I'll get a new cell. And in this cell, I'll just print C. And now what I should do is, you created C, right? That C is the new value. You have to now add C with the previous value, which is B. Right? C must be added to the previous value, that's B. Now B plus C. 1 plus B is actually 1, right? And once you add the return of this, that's C, to it, you add them, you get 2. So it's basically this. You, rather than showing it in code, I'll show it to you manually for now, and then I'll explain in code, okay? Rather, you start like this. You say 0, 1, then 0 plus 1 is 1. Now, what is 1 plus 1? 1 plus 1 is 2. Now, 2 plus 1 is 3. And now for those of you who are I'm not very clued, you might think next number should be 4. No, it's not. 2 plus 3 is now 5. The next number is 5. And 3 plus 5 is 8. 8 plus 5 is 13. So you can see that I'm doing this manually, right? The very act of programming is automating this. And 8 plus 13, now it's getting a little difficult for me to do the math. What's 8 plus 13? 13. Is it 20, 21? Yeah, right? Now 21 plus 13, I guess it's 34 if I'm not wrong. So it goes on. The series starts. You can build a series like this. You might wonder what is the use of it. Ask all the mathematicians, they will tell you, or even physicists and all kinds of scientists, they will tell you. Fibonacci is some kind of God series or whatever. Right? Anyways, so what it means that you will see Fibonacci everywhere. So it is a kind of series that's found in, people say, veins in a leaf, or maybe petals in a flower, or most of these natural patterns that you see around us is most of them fall in this Fibonacci series. They say when your facial structure, the measurement of your face structure, all falls in some kind of Fibonacci sequence, right? That's how we can call it. Now, from the programming standpoint, it's an algorithm, right? We take two numbers, we add them, generate next number, add the previous two numbers, generate next number, add the previous two numbers, generate next number. How do you do this? Using an algorithm. The way you do that is by this code, which I'm going to show you. First, let's take a user input. We'll just type, let's say, num is equal to int of input of enter number of Fibonacci series to generate. How many numbers you want to generate? And now what do you do? You could actually use for I in range of num. Basically, what I mean to say is that I want to generate the first 10 Fibonacci numbers or first 20 Fibonacci numbers. So I want to run a loop first 10 times or first 20 times. So I want to execute some series of statements first 10 times or first 20 times. Now, to generate a Fibonacci sequence, you start with two numbers, right? A comma B is equal to 0 comma 1. Now, normally what you need to do is that you need to add them up. You need to add them up, right? First, I'll print A. First value is this. I will end with a space for now. First value is 0. Then what we do is that we can just make A become B. A should become B. And B should become A plus B. If you come from traditional programming world, you will normally use a third variable. You will like to say maybe C is equal to A, store a temporary value, store the value of A in here. Then say A is equal to B, and then you would say B is now is equal to B plus C. Yeah, this would work. You know, it's very difficult for me to write code like this because I never do code like this. So I'm just trying to show you how it is done the traditional programming way, right? It's prompting for user input here on top. Let me say I want to generate the first 20 Fibonacci numbers. I'll type 20 here. You can see it worked. It would have been very difficult to do it manually on our own beyond some 10 numbers, right? You need to do a lot of addition now. The addition gets more and more complex with numbers becoming bigger. So we can see that the computer is able to generate it easily for us. Easily. 0, 1, 1, 2, 3, 5, 8, 13, 21. We did this manually for some time, but you can see it continued to 55, 89. It goes on. The number starts growing quite quickly, right? You can see that. The 20th Fibonacci number is like 4181. It's a big number, right? So there's just a 20th number, 20th value in the sequence. So this code is not Pythonic, obviously. That's why I struggled at it. These days it's so difficult for me to write unPythonic code. Python is so hardwired in my brain. How do you make this code Pythonic? Well, think about it this way. You want A to become B, and B should become the old value of A plus B. You can do that with a single statement. You don't need these 3 lines. Let me just keep this for your reference, but I'll just say old school non-Pythonic technique. To live with a language like C, even today, you have to use logic like this. But Python has support for parallel assignment, and that can be used to your advantage. When I talked about parallel assignment, I told you there are a lot of use cases for it. So I'm showing you the use case right now. So you can say A comma B is equal to B comma A plus B. That's it. It's pretty straightforward. If I try to give the number like 20 one more time, you can see it generates the sequence just like above, but with just one line. This is one example of how do you generate Fibonacci series in Python. So this is one use case. There are a lot of other interesting things we can do with a for loop. Let me show you one more example for this. Let's say I want to generate prime numbers. I want to generate prime numbers. You know what prime numbers are, right? These are numbers which can only be divided by themselves and 1 and nothing else. The most common by mistake is you want to check a number is prime. How do you check that? How do you check whether a number is prime? Let's say I want to know whether 19 is a prime number. You don't do this way. You don't say divide 19 by itself and divide 19 by 1 and say it's a prime number. Every number is divisible by itself and 1. But that's not what it is. But a prime number can only be divided by itself and 1, but none other numbers. Which means you have to check for the none other numbers. I mean, between 2 to 19. So if you want to check whether a number is a prime number or not, if you want to check whether a number is prime, check whether given number is a prime number. First, as usual, let's get the number from the user. So we can type it like this: int of input of enter a number. And now, how do you check? Let's say the number is 19. If I type a number like 19, how do you check it's a prime number? The simplest way to do it. There are many sophisticated, interesting algorithms to find out whether a number is prime. I'm not going to go to the most complex part. I'm going to leave it as an exercise for you to try out. There are a lot of resources on the internet to find different mathematical algorithms to guess whether a number is prime. There's interesting ones, Mercian primes and so many stuff like that. But I'm going to keep the simplest of it. It's called primal by division. That is, you try dividing the number starting from 2. Normally you should stop at the square root, but for now, let's not worry about the optimization. You can start the number from 2 up to that number, not including that, and try dividing 1 by 1, right? That's how you do it. So for this, you can use for I in range of, you need to start from 2 because you don't want to check a number whether it's prime or not for 1 because, from 1 because every number will be divisible by 1, right? There's no point of checking there. So you start dividing from 2 up to that number for now. Up to the number. And now when I try to, how do you check it? So you can just try if num percentage I equals 0. What did you read here? When you divide the number by I and you get the remainder of it because it's remainder of division. After dividing this number and you got a remainder, if the remainder is 0, this number is fully divisible. It could be, let's say if I give a number like 18 by 2, remainder is 0 because 18 is divisible by 9. So, 18 is divisible by 2, you get 9, right? 9 into 2, basically. So, the remainder is 0. If that remainder is 0, it's not a prime number. So, 18 is not a prime number. So, you want to just bail out and say not a prime number and come out. So, how do you do that? We can just say print not a prime number. We can say which number is not a prime number. For now, we can say num is, I'll put a capital not here so that not is highlighted. Okay, so it's not a prime number. And I can break out of the loop. There's no point of checking any further. The moment you know a number is fully divisible without a remainder, you want to break out of this loop altogether. Remember, break keyword can be used to break out of both the while loop and the for loop abruptly based on any other condition. So it's another condition I'm using here. But if it's divisible, if it's not divisible all the way through, you can say the number is prime. And how do you do that? Now, given here, usage of else clause is beneficial. So I can use an else clause here. Remember, the else clause is for the for loop, not the if condition, right? And here I can just type num is a prime number. Now let me try to run this now. But I give a number like say 18. 18 is not a prime number. Let's try 27. Not a prime number. No, 27 is divisible by 3. Yeah. Yes. Yeah. 3. 9 threes are, or 3 nines are, right? Try running it one more time and try 23. I guess 23 is a prime number. It is. We can see that. So it figured out that it's a prime number. How does this logic work? We can see that. First of all, this number, this statement, I guess you should be aware of. It just takes input from a user as an integer. We have been using it all through in various sessions, so this is obvious. The for loop, once you get the number here, let's say the number I gave is, let's say 23, for example, last time. The range starts from 2 up to 23, and 23 is not inclusive. That's the beauty of it. So you don't have to put that num minus 1 and all that. No, right? So 2 to 23, that means it generates range 2, 3, 4, 5, 6, 7. The last value that will be generated is 22, by the way, right? The stop index is 1 less than or lesser than what you pass here. I mean, the stop index, what you pass, the I value will never touch that, right? So, and now you check if the number is prime or not by checking if it's divisible. Check if it's divisible by 2. 23 is not divisible by 2 because you'll have a remainder 1. So this condition is false. You'll go back to the loop. Check whether the number is divisible by 3. Check whether the number is divisible by 4, by 5, by 6, by 7, all the numbers. And once it reaches all the way to 22, its number is not divisible by any of the numbers, then obviously this loop ends, right? Ends gracefully. This loop goes all the way to the end and figured out that it could not divide this number by anybody else. The loop ended gracefully, and when the loop ends gracefully, the else clause is evaluated. Just like in the while loop. The else clause is evaluated when the while loop condition becomes false, thereby ending the loop. When the loop ends to its completion, then the else clause is evaluated. Here the loop ends to completion without being divisible by any of the numbers from 2 to up to the number. So obviously 23 is reported as a prime number. But when you try something like, say, 24, range of 2 to 24 here, and you start with 2. Num percentage 2, that's 24, divided by 2, remainder is 0. This condition is true. It'll immediately print that is not a prime number, and it breaks out of the loop for here. Because this breaks out of the for loop, the loop does not gracefully complete. You broke out of the loop midway, then the else clause is not evaluated. Getting my point? So this is how the else clause works for a for loop. So run this a couple of times and you can see that. We can try a big number, let's say 127. 127 is a prime number. I sort of know it. Let's try 129. I think that's not a prime number. Should be divisible by 3, I guess. It's not a prime number. Now, when you start building algorithms, sometimes the logic is all fine. It's all working good. You need to look at ways to optimize the logic, especially when dealing with loops and also conditions many times. But loops are the first one that you don't have to optimize. In order to check whether a number is prime or not, the worst case scenario, it has to go all the way to the number. Let's say when try something like 127. To verify that the number is prime, it had to try dividing all the way from 2 up to 126. So it goes 2 to 126. That means that many times it's executed. So 126 minus 2, it goes to 124 iterations. These statements run 124 times before deciding that the number is a prime number, which means more CPU cycles is used. But we all know that no numbers are ever divisible beyond the half of them. If you take a number like 127, there's no point of checking whether number is divisible from the midpoint of it. Maybe it's, what does it fall? I mean, 127 by 2, what's that number? I think it should be 63 or so. I think 63 or 64, hopefully around that number, right? So if I try 127 by 2, I'm using double forward slash, low div operation. I'm on the integral division, 63. If you try dividing beyond 63, it'll never be divisible because you'll always get some remainder, right? Try this. If you say 10, you can try dividing up to 5, and very likely you might not get remainder if you say, you can figure out whether the number is prime or not. But beyond 5, divide by 6, divide by 7, divide by 8, you'll always get a remainder because the number is not divisible beyond its half. So we can reduce this execution of the statement by half the time, by almost half the time, just by adding this num by 2. But now I'm going to show you that it'll break. If I run this now, it'll throw a vague error. Okay, it's getting user input. It's a runtime error, right? If you just try a number like say 127, here's it. Type error. Float object cannot be interpreted as an integer. Where? Look up the line number. See this arrow mark shows you the line number. Whenever you look at the error might look very cryptic, very noisy. You have to try to, sear through this noise and figure out exactly where the error is. And first thing you notice, what is the error? What is the error? Note that first. And then figure out, oh, float object cannot be interpreted as an integer. What? Where? Next is where? This line. See, the arrow mark points to the line exactly. It also tells you here, line number 3 in the cell, and it shows the line number 3 corresponds to this particular statement. And it sort of looks like it highlighted where the error is also in here, I guess. So you can see that the error is because there's a floating point being passed to range. I would have told you maybe when I talked about floor div operator that there are certain expressions where when you perform some operation, you want an integer, but if you do a division by default always gives you float. Always, right? So division, even if the number is fully divisible, like say 10 by 5 will not give you 5, it will give you 5.0, which is a floating point type. And range is not compatible with float. All the arguments to range must be integers. You cannot generate floating point ranges. The built-in range does not support that. Some of you might ask, is there a way to generate values like, 1.0, 1.1, 1.2, 1.3, 1.4, 1.5? Floating point ranges? Range cannot do that. Alternative, you can use NumPy module. There's a third-party module. Comes bundled as a part of Anaconda, and NumPy is the super sophisticated matrix or array implementation. It's an n-dimensional array implementation and provides a lot of recipes to do matrix manipulation and algebra and stuff like that. It's a backbone for most of your data analytics and your machine learning algorithms on Python. It's the backbone. And everything is like either inspired from NumPy, any other ML models are inspired by NumPy, or they're built on top of it. That's how they are. Anyways, we are not going to be covering NumPy now. It's like too early. I'll be covering that in a separate training session again. But then here, I want to just make this floor div. I put double forward slash. The remainder of division, the division quotient is what is returned. It will not return the decimal values and all that. So the return value will be in integer, right? When both operands are integer, the return value will be in integer when you use floor div operator. We learned that when I talked about arithmetic operators, if you sort of recall that, right? So you can go back to the previous session, I think session 3 or session 4, I guess. You can have a look into that. You can check this out. So it's a num double forward slash 2. The return value is not a float, it's an integer, and it works. Yeah. It gives you the same outcome, but the number of iterations it had to take to decide whether the number is prime is reduced by half. We don't stop here. We can do further optimization if you know a little bit of more math. There is a mathematical theorem, I think it's by Srinivasa Ramanujan, I think. It's not the same person as the most popular mathematician, but another one with the same name, right? There's a theorem that was proven that he came out of the theorem and he tried to prove that if a number could not be divided within its square root, it cannot be divided anywhere further. Look at this. Take a number like 1000. Some number around 1000, 1003 or 1007 or something, which could be a prime number. Let's assume that for now. We don't know. We need to check that. If you try dividing till half of it, you need to make about roughly 500 iterations, close to 500 iterations, 498 or 500 iterations to verify that a given number is prime. In around that value of 1000 is half the value. Take the square root of the number. The square root will be much lesser. Let's say not 1000, let's say 10,000 is a great example. So say 10,000, I think the square root of 10,000 will be 100, right? 100 and 100 is 10,000, right? So instead of trying to go up to 5,000 iterations to decide whether a number is prime around that 10,000 and odd numbers, if you just take the square root of it, it will be less than 100. You saved a lot, right? You saved a lot. So instead of 500 iterations, you're able to check it in 100 iterations. take much larger number. The square roots of numbers don't grow at a much higher scale than half of the numbers. So you can actually find out in much lesser iteration. Yes. Sadly, if you want to be building algorithms in any language, any programming language, certain things, certain aspects, especially like things like loops, sorting, and all those algorithms, requires you to have some good understanding about your elementary mathematics. You might need to know much more if you want to do more sophisticated things like machine learning, let's say. But for your algorithms, you should have your the mental model for math working quite well, right? The more you have some good understanding about mathematical features and mathematical concepts, I think you'll be able to work on your logic and algorithms in a more optimal manner. Otherwise, you'll end up writing code that's not very optimal. You can also write a completely non-optimal code like I showed you earlier. I think I'll make a copy of this better, right? I'll just create a copy of the cell one without this division by 2 and one with this. But as I told you, if you want to further optimize this code, you can just copy this code and get the square root of the number. Now to get the square root of a number, one, you can use math.sqrt, but don't do that if you're a Pythonista. Number raised to its half, 0.5. But the problem is this would also return a float. You can't do something like floor div kind of a thing here. If you want to get the integer part of your computation, which could be a float, you can always construct integer of it. Remember, not typecast, construct. Construct integer from it. I keep reiterating this. Yeah. They'll give an integer value, but to be a little safe, I want to add 1 to it. I'll tell you the reason why. Sometimes, for some numbers, the square root could be closer to the edge, right? To the top edge, right? So I want to make it a ceiling value. So it's just add 1 to it. So if your square root is like 3.8 for some number, let's make it 4. There's nothing harm in just trying one extra iteration. Okay, so you don't lose out on a corner case scenario. So that's the only use case. I just made it plus 1 here and try this out. Let's try 127. It's a prime number. Let's try some small numbers. Let's say 2. 2 is a prime number. 2 is a prime number. Let's try 3. 3 is a prime number. Let's try 4. 4 is not a prime number. Let's try 7. 7 is a prime number. Let's try 17. And that is also a prime number. And let's try 29. That is not a prime. Oh, 29 is a prime number. Yes, 29 is a prime number, right? You can try 1331. That is not a prime number. That's divisible by 11. The moment I look at the pattern, it's divisible by 11. So let's try 1337. Not a prime number. Let's try 1339. Oh. 1279. Some magic number, is it? Oh, it's a prime number. You can see that. Yeah. 1279 is popular because of the famous mathematician Srinivasa Ramanujan, again, the one who lived in the early 19th century. A lot of theorems, whatever, right? So it's got to do with him. You can look up the history. So, but point is, you can check for a number is prime. Now, sometimes you're a little doubtful about how efficient your algorithm is. The multiple ways you can solve the same problem. Okay, you thought using this logic would improve the performance. But how do you prove it? How do you check whether the performance of this is a lot faster than before? There's a way to do that in IPython and Jupyter Notebook. You can do that quite well in Jupyter Notebook and IPython. And how do you do that? Well, let's try this. There is one of these interesting features that is there that can be used to instrument performance of any code, right? In order to use this, there's a magic called time it. The time it will just take one expression or a statement, execute it a lot of times, maybe sometimes 1,000 times, up to 1,000,000 times. It's very dynamic and it's mostly statistical in nature, right? It decides, like if it executes the first time, if it takes about half a second, it'll execute a few number of times. But if that expression takes, let's say, maybe microseconds to complete, the expression is evaluated in few microseconds, then it'll execute it maybe 1,000 times or maybe about 10,000 times or so. So it dynamically decides how many times to execute to get a better average, because on your computer today, we have a lot of things going on. It's not just that I'm running this VS Code. I have my OBS Studio that's recording this entire video. Plus, I have browser windows open. I have a lot of things going on, and the underlying operating system has a desktop and things. So the CPU is being shared by a lot of programs running. So testing your program's performance, getting the accurate value, is very difficult. So the best way to do it is you run the program multiple times, thousands of times, and then you get an average of them. Sometimes your program will be given more CPU cycles while the CPU is being shuffled across by multiple applications, sometimes less. But when you get an average, you get mostly a realistic number on how efficient your code is. It's very elegantly done in IPython. I like this feature. But the problem with timeit is that it works for a single expression or a statement. But if you want to make it work for a block, you have another variant which is double percentage timeit. Double percentage timeit. If you want to know how to use this kind of magic commands too, you just put a question mark before in IPython and Jupyter Notebook and put this below. So here it shows time execution of Python statements or expression, and you can either use timeit and there are a lot of options and you can give a statement, or you can use, or in cell mode, timeit, and you can provide the actual code below. The way to check this is you need to put this in a cell. So what I will do now is I'll still have to make a copy of this. I'll do one thing. I'll take one of these variants. I want to drop that input function. You should not use user input when you're using timeit. It's going to ask input like 1,000 times. You don't want that, or 1,000,000 times. Sometimes you can run 1,000,000 times. Not a good idea. You don't want to keep typing the same input 1,000,000 times. No. So we'll take the input separately, and then we will try to run the 3 different logic and time them up. So I'll copy this cell for now. The first one, which was slow. Paste it here. I want to split this cell. If you want to split a cell, just go where you want to split. Just press enter. When you're in edit mode, just use Control Shift J. Didn't work. Okay. I think some of the shortcuts are not implemented in the Jupyter Notebook in VS Code. Sadly. No problem. Is there a way to do it? Help. Join cells. Oh, there's a join. There should be a split. I'm trying to see what the shortcut of that is. Oh, it's Alt, is it? Maybe it's Alt, perhaps. Alt Shift J. Nope. All right. Didn't work. Let me figure it out. There should be a way, but the shortcuts could be different because I'm using VS Code. But if you're running your standard Jupyter Notebook, which will launch from your Anaconda prompt and you get in a browser, remember I showed you that. There you can actually use this Control Shift J to actually split a cell into half, right? So for now, let me save time. I'll just copy this all together and put this in another block below. I'll take the number from the user separately. This cell is going to run separately, and whatever number I get from this cell, I'm going to use in 3 possible cells to check whether the number is prime. And let's try with let's try with 127. We know it's a, or 1279, the magic number. That's a prime number, right? Let's try that. 1279. I could also hard coded that. Shouldn't be a problem. Now here, I'm just going to use double percentage timeit. If you want to make some of the magic commands, you're going to make it on a block of code in a cell. Within a cell, they will generally have a double percentage to it, right? So you put double percentage timeit, and then you have the code below. Let's try running this. It's going to execute this sometimes. Oh, okay. This is a bad idea. It's going to print is a prime number, is not a prime number multiple times. But it took about 4.9 seconds. This also timed the time taken to print this number. Okay, print this number. So if at all you want to optimize, you don't want to consider the overhead of printing them every now and then so you can see it executed a lot of times. See this? Or it shows below. It took about 61.4 microseconds, plus or minus 4 microseconds per loop. The time taken for the actual CPU usage is this, but print adds its own delay, and that delay is what is shown as 4.9 seconds here. But what I'll do right now, I'll just try to comment this off. Now, if you try running this, it'll throw an error. I'll tell you why. If you have a block like else block and you don't have any body in it, or if you have any compound statement, but the body has to be empty for some reason, temporarily, for example, you can just satisfy the syntax grammar by using pass. Pass is a simple statement in Python. It can be used in any compound statement as its body. When you put pass there, it means do nothing. Then why is it there? This is just to make sure the syntax grammar is correct. It's a limitation with the Python syntax grammar checks. When it sees a compound statement prologue, it has to see some simple statement in it. If you want to say that there are no simple statements, this body is empty, you can't just leave it blank. You have to just put one keyword called pass to tell Python, okay, do nothing. And that's what it is. It's just to satisfy the Python syntax grammar. Run this, and yeah, 49.4 microseconds. That's the average time it took to check whether number is prime using the technique where I'm not even dividing by 2, right? And it takes plus or minus 2.79 microsecond per root. So the standard deviation, it's decided based on mean standard deviation. It ran this code 10,000 times into 7. 7 runs, each run 10,000 times. So 10,000 times when it runs, it takes the average of it, and out of 7 iterations of this execution, it gets a standard deviation and prints it, right? So it gives you a more statistically accurate value, right? So I'll just copy the same code. This time I'm going to use num /2 here. And when I run it this way, you can see this. It finishes roughly half the time if you observe. Last time it was like 49.4 microseconds, but now it finished in 25.1 microseconds. You don't have to run this multiple times because this is doing it anyways for us. So you can run it once and we can be quite sure about the performance metric, right? So you can see the time taken is reduced by half. But now if you want to use a square root function, some of you might argue finding out the square root is CPU intensive. But you'll find the square root once per execution, but you'll run the loop, right? So that matters. These are things you keep in mind. Are you running certain complicated operations multiple times or not? All that matters. So I'm just going to use int of num to the power of 0.5 to get its square root. And I'll add a +1 to it. The end. Run this now. I put a percentage time at magic on top. I just copied the previous cell, by the way. Run it now. Wow, it's taking so much time to run. But you can see that it finished in 1.3 microsecond. But why did this cell take more time to execute? Because it ran the loop more number of times. The reason is because the first time it ran, it just gave this entire expression, this entire code executed in 1 microseconds, let's say. They said, to get better averages, let's run this more number of times. The time taken by an expression or a code, right, is much lesser, is slimmer. Then it'll execute that more number of times to get better averages, to avoid the operating system introduced jitters, we call them, right? So I think I'm getting too technical here. So let me tone down. All right. So you can see, however, that 3 different logic, not different. The only subtle difference is that to what extent you want to execute the loop, right? You get the same outcome. But here's a proof that this is the slowest. This is okay. And this made it way faster. Right? So using proper logic, a proper algorithm, you can actually make your code more optimal while doing the same thing, right? If you're using any kind of looping constructs, be it a while loop or for loop, you should try and check if you can, you should know why you're using a loop first. That's the more important thing. And if it's for solving some problem like these, you can check, can you solve the problem using lesser number of iterations? Is there a way to do it using lesser number of iterations? And that is the first direction that you take a step in the direction, right? You find out how can you reduce the number of iterations while you can arrive at a solution. Next thing you need to do is reducing the number of conditions. The more condition checks you perform, the more impact it will have on CPU. CPUs are slow in comparison, all CPUs. There's a lot of things going on in the computer when you're trying to compare things, right, in a CPU. So one of the things that people will talk about is about cache, your CPU cache, right? Branch prediction and cache, all these things play around, and it hurts the performance. I'm not going too technical in this session about it, but just using some keywords or catchphrases for you to look up, right? So if you want to make your code more optimal for your CPU cache lines and cache memory, one of the first thing that you'll do is reduce the number of branching instructions. That is conditions. Conditions are like branching instructions. Go to this branch of code or go to another branch of code based on a condition, right? The lesser you have, the lesser, penalty the CPU had to face in running this code. That's the one thing that you look for, optimization. This is generic feature in all languages. There are some compiled languages which are super smart. C, for example, today's C compilers are very, very smart when you use optimization flags. They analyze your code and figure out whether you can optimize your code better on their own. They'll try to reduce the number of loops. They do loop lifting. They do branch optimization and stuff like that. So code lifting, that is, right? It's called as loop unrolling and code lifting and branch optimization. They use all these kind of techniques when you use optimization flags in C compiler. And language like Java also has them, and runtime. There's a lot of runtime optimization that JVM actually has. Python, it tries to optimize not the execution as far as my knowledge goes, but it does optimize how data is managed to some extent. Numbers and strings are optimized, that much I can tell you. There are some optimization that's happened in the implementation of dictionaries recently. So this is the kind of things that keep evolving over the language versions, right? Anyway, so I just gave you an example of how to use a for loop. Started from something very simple where we started to iterate over a range of numbers. I told you how to iterate over collections. And then I told you what are the things you can do with a for loop. One, generating a Fibonacci series, where I talked about innovative way to do it using parallel assignments. And then a really interesting one to check whether a number is prime. Now here's an exercise for you to try out. If you're able to solve it, mail them to me. And yes, as usual, don't go to ChatGPT and ask the question and get the solution and paste it. It doesn't make sense. I want you to try it. I want you to put in effort and try it. And let me know if you're stuck. That's the best way to learn, right? So if you're, as I keep telling you, you go and put it on any of these language models and try to solve them. They'll give you the solutions. The solutions are readily available, but then you're not learning, you're training the model even better. You're reinforcing the model there, okay? Reinforcing its training. So the exercise is to generate the first n prime numbers. What I mean by first n, take a user input. If I type 10, I want you to generate the first 10 prime numbers. Zero, you don't start prime numbers with zero, sorry. Start from 2, right? Not even 1. Start from 2. So you say 2, 2, 3, 5, 7, 9. No, 9 is not prime number, sorry. 7, 11, 13, what else? 17 and 19. And after that, I think you get 23, I guess. Yeah, 23. The first 10 prime numbers. Likewise, if the user input is like, say, ask for user input, enter number of primes. But type 20, similarly, first 20 prime numbers must be generated. Remember, it's not prime numbers up to 20. No, I don't want to generate prime numbers up to 20. I want to generate the first 20 prime numbers. I hope you got my question correctly. Try it out and let me know if you can solve this. Try, right? I'm not going to give you any hint on how do you go about it. So I want you to put your thought process and see if you can solve it. If you're able to solve it, just put something on comment. Just say, I was able to crack this on my own. That would be like a big win for me, right? Yeah. Thank you very much. So, as usual, if you really like what I'm doing, if you really like all these concepts I'm covering, and if it's really adding value to you, do let me know by pressing the like button. By more likes, I know more people are really liking this video and finding it valuable. So do like this video, and yeah, as usual, share, subscribe if you're not already subscribed, and yeah, I want to see more people who watch this video. Thank you. Meet you in the next one.